Hello, everybody. I'm Henry Lindner, and I thank you for the privilege of being able to be here and present my ideas. These ideas have been very important to me since the 1990s, when I came up with this, essentially different approach to physics than what I had discovered. And I'll describe that journey a little bit. Dedicated to my daughter, after I had developed all these ideas and published a couple papers, my daughter, for reasons of her own, decided to study physics, mathematics, and astronomy, astrophysics. She was the top STEM student, basically, at Penn State when she graduated, and she finished all their graduate courses, the required courses. So I had this wonderful opportunity to have this relationship with a person who was going through the whole process of education in physics up to the PhD level, and she had many discussions with professors, and so I got to hear how those discussions went, what the objections they raised were, or the explanations they tried to give for their physics. So I kind of had a surrogate experience of being a student in physics all the way to the PhD level. The problem we're dealing with is philosophical. And I'll explain where it came from, why it exists, and why physicists don't understand the nature of the philosophical problem. But, to put it briefly, they believe they have physical theories. So they're content that their models tell them how the physical world works. But they don't realize that these were only constructed as mathematical models of the observer's observations and measurements, as Einstein said, with their rods and clocks. Also in quantum mechanics, then it's photomultipliers, colliders with their detection devices. The result is we have this ongoing confusion. We even get a lot of nonsense when they think about or try to apply their mathematical models to some sort of description of the real world because it doesn't work. And so this problem is philosophical. It is not scientific, so to speak, and I'll differentiate between those two. And it has to be resolved by a philosophical revolution. So I need to define what I am talking about. What is philosophy? Because everybody today believes in science, but they think philosophy is just some fluff that you add to, talk about nonsensical things. But in fact, I define philosophy as the entirety of our attempt to understand reality, including ourselves, our consciousness, what the physical world is and how it works. Its primary method that differs from what most people consider scientific method is that its most powerful tool is theory. We create theories to explain what we are, what we're experiencing, what's causing things like, wave-like phenomena, and so forth. It involves a mastery of language. Most of our disputes are about the meanings of terms, and I call them verbal disputes. And also, people are trapped by their linguistic formula. They don't really, they don't understand that the words are just, devices somebody created to represent something. And in order to think clearly, you have to know exactly what your words mean and criticize them and analyze them. Philosophy is about integration. You really can't understand anything in this world without understanding everything. It's because everything is interacting. It's one cosmos. It's one entire system that is interacting all the way from simple spatial phenomena like light and particle formation all the way up to linguistic consciousness that we humans have. And I want to stress this as my view of philosophy and its relationship to all our other ways of gaining knowledge, which is that logic, mathematics, and the scientific method are tools of philosophy, tools of our overarching, attempt to understand the world. And notice the scientific method is one of those tools. And it is not by itself a freestanding intellectual entity. It needs to be informed by ideas, criticized by ideas, and so forth. And what do? We try to make sure that our linguistic formulae, and that's what we're all using, is language-based formulae. They need to correspond to cosmic reality, and these are the tools we use to make sure they do. Our heritage is natural philosophy. And, these names are the most hallowed people in our history because they took us from ignorance of how the world works to knowledge. Aristotle himself essentially educated the Western world with his works on logic. Copernicus was very clear about the fact that he was differentiating between the appearance to the observer and the reality of what was happening, as recently showed us in terms of his example. Galileo was not a mere scientist, he was a natural philosopher, and he spoke of natural philosophy as the reason why we don't accept equants, deferents, and epicycles from the Copernican system. Isaac Newton also was an objectivist in the sense that he said we have to abstract from what our senses tell us to try to figure out what's really happening. And then we have Charles Darwin, who basically had a very large role in creating the modern world, and he too called what he did natural philosophy. And he even mentioned, he understood even that Copernicus's theory was hardly supported by any direct evidence until much later, and that his theory of evolution is not an unsafe method of arguing. It's what we have to do to try to understand what's happening behind the appearances. Sciences are branches of philosophy, all of them, and they need to remain branches, as I will show you from Francis Bacon soon. Thomas Kuhn, The Structure of Scientific Revolutions, is a key to understanding how sciences evolve. And what is happening now is what has always happened. They work within a paradigm. So all our physicists and all our universities all over the world are working in this relativity, quantum mechanics paradigm, and they really can't see outside it or beyond it. And everything that contradicts their paradigm or doesn't fit, as Thomas Kuhn said, they recategorize it, or they just ignore it. They try to make it fit into their paradigm, but it doesn't fit, but they don't care because they're not actually thinking philosophically as they should. And these defective paradigms persist until they're replaced by an act of what? Of scientific revolution? No, it's actually an act of philosophical cognition, because it has to be something above the paradigm, above the, outside the paradigm. There has to be intelligent thought to consider the paradigm false and replace it. And just consider Copernicus replaced an observer-based paradigm with an actual paradigm of what could be existing and causing this, which is a heliocentric system. And Darwin replaced a God-magic paradigm. Everything, the species exist by magic, we don't have to explain them. And Darwin said, no, they evolved through some kind of natural process that we need to explain. And that put biology on a true course, unlike physics, which is still on a false course, in a false paradigm. My journey, in a way, began with Ayn Rand because I was raised as a fundamentalist Christian by a mother who needed me to believe that stuff very badly. And not till I left home did I start to think for myself. And it took me many years to deprogram myself from fundamentalist, spiritualist Christianity to some kind of philosophical understanding of how the world works. And I read Ayn Rand. I read everything she wrote because she had these ideas that actually turned out to be important to me, which is she distinguished between the primacy of consciousness and the primacy of existence as two metaphysical paradigms one could possibly adapt. Primacy of consciousness is also called subjectivism, and it just holds that all there is our consciousness and its experiences, and we should just try to describe, our sensations and measurements because we don't know what exists outside of consciousness. But primacy of existence is called objectivism, and therefore you do posit some external reality that is causing you to experience what you do. And then once you do that, you can theorize about what it is and how it causes it and so forth. Where subjectivism really leaves you trapped in description, because you're just dealing with your own consciousness and not talking about any physical causes. When I was trying to deprogram myself, I once decided, well, I have to figure out what this cosmos is and how it developed. So I developed a simple outline of the evolution that has occurred. And these are the major levels of cosmic evolution, and each has many sublevels. So in essence, if you flesh this out, which I did it initially, and you can see it at my website, it's my old or initial version of this, there are many, many sublevels, and they involve different levels of interaction between the lower level entities to produce some new kind of entity that does something else. For instance, all that we need is a system that produces the 3 subatomic particles, and those combine to give us 80 atoms. And those combine to give us immense numbers of chemicals that basically, of which stars and planets are composed. Then some molecules started to replicate themselves, probably RNA. And eventually we got this whole evolutionary system we call life. Some of these things developed brains that are complex. And so we have neuropsychological reality. These are all levels of reality. When humans got language, they were in at first what I call the linguomythic stage. They did not have philosophy as we do today. And so they described everything according to myths. Gods, magic, you name it, that's what civilizations were all based on, and indeed still are based upon. But our potential, our human potential, is philosophical. We have to move beyond all myths, beyond all inadequate paradigms, to understand what the cosmos is, how it made us, what we actually are, not spirits in a material world, but we are part of this world. We are the world. The cosmos becomes self-conscious through its own evolution. So, back in 1990, I had this little book with me, and I had a lot of free time. So I said, okay, Einstein will tell me what everything is made of. So I read his book, okay, mass energy space-time. And my original outline had mass energy and space-time as the cause of everything. But as I read it, I realized these are just measurements with rods and clocks, as Einstein puts it. And indeed, he was just describing the observer's measurements and not producing any theory of what caused them. So it's a purely primacy of consciousness, subjectivistic system. If you try to apply it to the real world, problems occur, which I will show. One of the major ongoing misunderstandings, as I mentioned in the first slide, is this idea that space-time, because physicists are really objectivists, they believe in a cosmos and they believe in physical causes. They don't believe in subjectivism. They don't believe consciousness is all there is. And so they turn the current physical concepts or current concepts of these subjectivistic models into real stuff, so it makes sense to them. And one of them is space-time. You'll hear them say that things are moving in space-time, or space-time curvature causes gravity, and so on and so forth. When in fact, space-time is composed of intervals. And the interval is just the observer's measured space and time, intervals with their rods and clocks between events. So it's a highly abstract, four-dimensional continuum of past, present, and future that has no real physical meaning whatsoever. It is just a scheme that does, in some cases, coordinate the intervals, or the observers will get these same measurements because of certain laws or factors. And Einstein is on record as saying his interval has no physical meaning or significance. He never tried to say it did. And so we have a misunderstanding, a huge misunderstanding. He made these very clear statements about his philosophical approach. He said that we're just trying to find regulative connections between our senses, our sensual experiences. The only justification for any of our ideas is that they represent the content, the complex of our experiences. Without this, there is no legitimacy. So if it's not just something representing what you're measuring or experiencing, it is illegitimate. This was his thinking, and that was, in 1922. Then he claimed, and Alexander doesn't want to believe me on this, but you can find I'll be happy to photocopy the page. But in The Evolution of Physics, written in 1938, he said, and he is actually accurate, that relativity renders the Copernican revolution meaningless, or the debate between Ptolemy and Copernicus, because Einstein said you can use either reference frame with equal justification. Now, he had to say that because he's still proclaiming that relativity is true. But in fact, it seems to be nonsensical to us or to anyone else, because without Copernicus, there was no subsequent physics. There's no Kepler, there's no Newton, and there's no Einstein. And to make this point, this is the Ptolemaic system. This is what you get when you leave the observer as the center of your system of thought. And indeed, it has no physical reality, the deference and epicycles and equants, and it's a dead end. So if we had not escaped from this system, we would never have learned anything about anything. And relativity and quantum mechanics, I will claim, have exactly the same epistemological status. They are just equants, deference, and epicycles. They get the predictions right, as did Ptolemy, but they do not do so based on any plausible physical theory. And so indeed, all their contents, all their concepts are observer-based concepts like deference, equants, and epicycles. And that includes space-time intervals, time dilation, photon, virtual particles, particle exchange, the wave function, its collapse, the Higgs field and Higgs bosons. All of these are concepts that are part of a subjectivistic system to get the predictions right, but have no physical meaning, exactly like deference, equants, and epicycles. They represent in some way some aspect of reality, but not directly. That has to be figured out. So why are we stuck in this day and age, after Darwin, and with all we know about humans, their evolution, the brain, language, why are we stuck with subjectivistic physics? Well, one of the proximate answers is that there were a lot of questions about the ether, as someone mentioned, Dr. Chang. Where is it? How does it work? Where does it go? Why is the Michelson-Morley experiment negative? And so on and so forth. And so in one sense, you could cut the Gordian knot of all these difficult questions by saying, there is no space. We're just going to talk about what the observers are measuring. So that's a kind of rational explanation for why this happened. Restricting physics to, mathematics and what observers sense and measure. But the question is why Einstein did that. And that took me on an investigation into the whole history of philosophy to understand. But he was very clear. He repeatedly credited Hume and Mach for his approach to physics, over and over. And who were they influenced by? Well, a man called Bishop Berkeley, which I will explain. But before getting to Berkeley, we have to go through the whole history of Western civilization and philosophy. But briefly, it's this. Western Christendom, Christianity was universally accepted, basically the world I grew up in. But they had Aristotle's works. So you can read throughout the Dark Ages, they were reading and commenting on Aristotle, but they only had his works of logic. And I think this is literally why the Western civilization became philosophically competent, because logic was incorporated into, the monasteries, the monks, the people who were doing the thinking and writing. But there was conflict between the two. The Byzantine Emperor Justinian, he was in the Eastern Roman Empire in Constantinople. He closed Plato's and Aristotle's schools. We don't want this. More importantly, Aristotle's later works came to the West through Spain, through Islamic Spain, because the Muslims had preserved them in their original form. And when the church got all these new Aristotelian ideas about the cosmos and its prime mover and how it exists as an entity independent of the human mind and consciousness, they condemned his theses, and including Aquinas, who was very much an Aristotelian, who was trying to put Christianity and Aristotelian philosophy together. But the entire project was condemned by the church, and that meant it's forbidden. Excommunication can result. So afterwards, or shortly afterwards, we have a very important figure, William of Ockham. He was a friar, And he said he tried to separate natural philosophy from Christianity completely. And how do we do that? We don't posit any God-independent causes or mechanisms. We only talk about our experiences. And he said using the fewest propositions necessary, which is a good idea, but that actually is the origin of his razor. If you think about it, the easiest, simplest explanation for everything is it's magic, God just does it, it just happens, which is how our theoretical physics works today. So here are two major thinkers that influence Western thought, Descartes and Locke. And if you read what they have said, it was very clear that they were stuck in the primacy of consciousness. And that's Descartes' famous, I think, therefore I am. He should have said, the cosmos exists, humans evolved, my mother was born, and my mother gave birth to me, so I exist. I mean, that's the actual cosmic view of what happened. But no, he's saying, all I know is I'm conscious, therefore that's the only thing I know, and I exist. And he even branded, and these are both Christian men, he even branded theorizing about final causes, which is really cosmic causes. He said it was a sin. And so we get from Descartes this idea that we should just have a universal mathematics. Everything should just be describing, motion, number, and so forth. And he invented the three-axis coordinate system for this reason. And we still use it today. It's at the heart of space-time. Also, John Locke said, well, we're more certain of our spiritual than any physical existence. So he is the father of what we call empiricism, which has this subjectivist contamination, because an empiricist will just describe what they experience, the ideas that are presented to the senses, and we can't pass beyond those ideas or our experiences. So we should just describe those experiences and never pass beyond to understanding any hidden causes. And so this brings a problem, which is the problem of dualism, is that. And these two tended to actually also believe there was a physical world. So they believed in two realities, consciousness and cosmos. This spirit and matter. And dualism has a major problem. How do these two utterly different realities interact? Where do they interact? Why do we have two? Well, a seminal thinker solved this problem in this way. He said, okay, there is no cosmos. And indeed, he wrote about the fact that Copernicus' theory and Newton's model even were threats to Christianity because they basically held that the world operated on its own way, separate from our mind or from God. That is raised against Newton's theory very often. It's like there's this mechanical universe and it doesn't need God. So it tended to threaten Christian beliefs to a degree. So he said, there is no cosmos. There is only our consciousness and its experiences. What's causing them? Well, there is a real reality, but it's a matrix created and run by God. And that's exactly like the movie. So if you watch the movie again, think about the fact that, this is Bishop Berkeley's theory. In the movie, it's the machines that create and run the matrix and plug the human minds into it. In Berkeley, it is God and there's only spiritual reality, and he's feeding us this illusion. And there's the one problem with that, it turns God into a deceiver, if you think about it. That there is this external world that seems to be operating by its own mechanisms, but it's an illusion. And so his conclusion is, as you would imagine, we should only describe and mathematically model the experiences God gives us. And so he defined, he essentially got rid of natural philosophy and said, there's only this science. He didn't call it that, but I will call it that because that's what it is today. Should only seek the rules of the matrix. David Hume, one of those figures that, Einstein said was a source of his thinking. He read modern philosophy extensively. Was a skeptic. He said, well, we really can't tell that there is a God matrix, like Berkeley said, or even a physical cosmos. So once again, we should just describe our ideas and the relationships between them, because we don't know anything else exists and shouldn't try to talk about it. So he even reduced cause and effect to custom, meaning we don't know what's causing this effect, we just know that we have this experience. And he claimed that we will never know the cause of a custom like gravity. It's just a custom that things tend to fall. We can never know, it's just something in our experience. And so, in a sense, philosophically, this is nonsensical, because he rejected the metaphysics of Berkeley that, justified only describing our experiences. Because Berkeley said, there is a cause, it's God and his matrix. But no, Hume said there's no cause, but still we should only describe our experiences and measurements. And Mach was also considered a major influence on Einstein, and he was especially so in his younger years, which changed a little bit. But Mach was a very clever guy, and you will see that I am a fan of Mach's principle. But he denied that the cosmos exists, and he denied that God exists. He's an atheist. And so, because again, we only know our sensations, so that's all we should do, is describe our sensations and measurements. He reduced physical laws to relations among our sensations, perceptions. He redefined theories as mathematical models of our sensations and measurements. This terminology persists today, and it irks me because it's misleading and it keeps people trapped in this paradigm. Mathematical models are not theories. They are just models. They are just ways of putting the numbers together to get a system that works. A theory is a philosophical attempt to explain things. As you know, he refused to believe in atoms at that time because they were not evident, but atoms were necessary to explain chemistry, gases, all kinds of things. But he said, no, we haven't seen them, so we should not believe they exist. And he never spoke of natural philosophy. He essentially replaced it with science, and he used the term science. So I really see him as the father of modern science with a capital S, which affects not just physics, but every field. And I know because I'm involved in a lot of them. So his science is modern science, and it's really anti-philosophical. As I define philosophy as trying to understand what exists and what causes everything. So it's observer-based, merely descriptive, anti-theoretical, and one can say stupid. Not him, but the ideology of never talking about what exists and causes these things. It's like voluntary stupidity on the part of the human species. So this is a long slide, but it's very important to understand how Einstein's thinking evolved, because he ended up being thought of, as he is today, of like a natural philosopher or an objectivist or a classical physicist who talks about what exists and causes things, space-time curvature. But in fact, when he was young, he said he was very much influenced by Mach and this idea that you should only describe your sensations and measurements. But he had an idea that you have to go beyond that. Sort of like he would posit that atoms exist. Einstein would, but only at reality as thought, only as like a freely created concept which helps us to make sense of what we're experiencing. And he believed in an external world, independent of the perceiving subject, but he defined it intersubjectivistically. Now that's a little confusing, but what he means is what we, as observers, what we share, what we agree upon, what we both measure, like the interval between events, that is reality. It's intersubjective. It is not some physical thing we can talk about, especially not an ethereal space through which things are moving and light is a wave. So all his concepts literally are like Ptolemy's deferents, equants, and epicycles. They're constructions of human thought to provide some organization to the sensations and experiences we have. So he kind of goes beyond subjectivism and Mach and Hume, but where does he end up? Really back at Berkeley. Because it's exactly like Berkeley's matrix. Einstein was looking for the laws of the matrix, the laws that would explain why we are having similar experiences and can agree upon various things. as observers. And he rejected quantum mechanics for this reason. I've read that. I can talk about that argument or problem at length, but quantum mechanics doesn't produce any deterministic rules of the matrix. It's all probabilities, and because he's a Berkeleyan, essentially, he found that distasteful. So consider the elements of relativity. It goes way back into Protagoras, who was a Greek thinker, who said that man is the measure of all things, and Sextus Empiricus said, look, Protagoras said that what appears is all that exists, and so he introduces relativity. The word is used there in the translations of Sextus Empiricus. Bishop Berkeley spoke extensively about how we should only talk about relative spaces and motions because we have no knowledge of any absolute or cosmic. Ernst Mach also was a critic of Newton's absolute space, said it's devoid of content. We only know the relations between things in our experiences, which is relative motions. And he coined the term relativists, by the way. And again, this is all coming from a standpoint of primacy of consciousness. There is no cosmos in relativity. This is very obvious. And it's obvious if you look at the three axioms of special relativity. It only describes coordinate systems and measurements supposedly made between two coordinate systems. There's no mention of a cosmic frame or any cosmic reality except the observer's measurements of these phenomena. And the differences are described by the Lorentz transformations, which he took wholesale from Lorentz, as we know. He solidified this kind of meaning of relativity in phrases like this: there is no such thing as an independently existing trajectory. There's only a trajectory or relationship between two frames of reference or two objects. And by independently existing, imagine what that does. That rules out the cosmos. A cosmic space, planets, stars, galaxies, they play no role in special relativity. It's only frames and their relative motion. And critically, light's motion is not related to any cosmic frame. It's said to move at c in every frame, which is an absurdity, a complete non-physical absurdity, that the same light moves at different velocities in different frames, moving relative to one another. It's just a nonsensical assumption that he needed to produce a system without the ether of Lorentz. So no physical space means no physical cosmos, which means no physical causation. And this, again, is just looking for the rules of the matrix. Relativity, apart from what people say, actually never worked at all. It was false from its inception. It didn't work, and it still doesn't work. And here's your proof, the twin paradox. So-called paradox because contradiction would be too obvious, wouldn't it? So in relativity, there is only the two frames. And all differences should be mutually observed between two co-moving frames. Each one sees the other's clock run slow and length contracted and so forth. So the paradox comes when they come back together, one of their clocks typically actually is running slow and slower than the other. So how can you get this asymmetry when relativity predicts pure symmetry between the frames? Well, to do so, you have to introduce a third frame. You have to introduce the very thing that he said did not exist. There is no independent trajectory. Well, they have to introduce it surreptitiously. And Dialec's group has made tons of videos about how this doesn't work. But what they do is they invoke Newton in a sense. They say there's absolute acceleration, although motion is relative. They say that one twin changed frames when he turned around and came back. Well, that means they changed frame relative to some other frame, relative to some space. And so really, the fact is they are trying to rationalize a paradigm that doesn't work. So they are confused and they remain confused. And if you challenge one of these explanations of the twin paradox, they'll pop up with another one. And then they'll pop up with another one. And none of them make any sense. Yes?
When you change exchange energy between your environment. So the frame change is real.
Yes, he said when you change reference frames, you change energy. You exchange energy with your environment, so that space or reference frame is real. That's another way of looking at it. So there is always asymmetry and inequality. There is never true relativity anywhere. General relativity, if you look at its ideological structure, it was his attempt to generalize the principle of relativity, so that not only inertial motion through space or relative to some other frame would be included, but now acceleration and rotation were supposed to become generalized. He literally was looking for a set of laws of physics that would work equally well for rotating and accelerating frames as for frames in so-called inertial motion relative to what? Space. And so that was his conception of general relativity. But it was nonsense from the very beginning. There's no way you can relate laws of physics to accelerating and rotating observers, especially he even mentioned randomly accelerating and rotating. He believed he was going to find the laws of physics that would work for every single one of these situations and so have a general relativity, again, without any cosmic reference frame or reality. But in fact, it didn't work. It never worked. But he did come upon this principle of equivalence, which was a brilliant insight. And he basically tried to turn that into a relativity theory, but it is not relativity at all, as I will explain. So he came up with this space-time curvature, which is, again, just a mathematical model of observers' experience and measurements. It is not a physical reality, as all physicists attempt to claim. They think that mass is curving space-time, and this is the cause of gravity, and so on and so forth. They don't know what they're talking about. And it is observer contaminated, like special relativity says that light moves at c in every inertial observer's frame. He said that general relativity still holds that light moves at c in every free-falling frame. So every frame of thousands falling towards the Earth at different velocities, general relativity holds that light is moving at c in both directions in every one of those frames. There is also no cosmos at all in quantum mechanics, and this is actually not controversial. Although not understood or believed, it's not controversial, because this is a great textbook. If you want to study QM, my daughter said this is the best. Resnick, very good. And they make this statement: quantum mechanics rejects as meaningless and useless the notion that behind the universe of our perception there lies a hidden objective reality, a world of causality. Indeed, it confines itself to the description of relations among perceptions. So if one doesn't understand this about quantum mechanics, you end up in utter confusion forever, which is where most physicists are. They think their photons are real, they're traveling from here to there. I have a whole nother lecture about that, what actually is clearly happening in quantum electrodynamics. And it is an ad hoc model. That is what it is. It is not a theory. It is not the greatest theory in physics. It's ad hoc in that it has been massaged over decades to get the right answers. And any history of quantum mechanics, you'll see that over and over. Feynman admitted it. They had to measure things and stick them in and then change the math to get the measurements correct. It models the observer's information. It doesn't model the cosmos. And this is all clear. And so you get all this quantum spookiness, and it goes on and on. Non-locality, the collapse of the wave function, observer-created reality, and on and on. And it's all garbage because it's a subjectivistic system from the start, and so all it outputs is subjectivistic ideas. How am I doing here? Okay. He was a mathematical idealist of the Platonic kind. So, he said nature is the realization of simplest conceivable mathematical ideas. He was a Berkeleyan theist. He did say that God is a superior mind who reveals himself in the world of experience. And probably most of you are familiar with this statement about the fact that general relativity requires an ether, but he specifically said you can't give it parts or motion. So he literally forbade, creating a physical theory that made any sense. So what he's left us with is contradiction and confusion. He didn't eliminate the ether. He admitted he didn't eliminate the ether, but he didn't go back and say relativity is wrong. So he's left everybody in confusion. He admitted, that he was inconsistent in his approach to epistemology. He called himself an unscrupulous opportunist. Well, in philosophy, inconsistency is death. It means you are not doing philosophy properly. The problem, physicists are not philosophers. They are trained into these models, from textbooks. And the academic philosophical system just accepts relativity and quantum mechanics as true and a true approach to understanding the world. So we have acceptance of subjectivism, contradiction, unreality, and really what has happened is the destruction of natural philosophy in general in our culture. So it's 120 years of corruption. I'll get going a little faster here, but this is what happens when you do not have philosophy in your culture. You get all kinds of fallacies, contradictions, flawed arguments persist because we need to think philosophically to understand them and replace them. So you have false paradigms everywhere, and I've encountered a few of them. I'm recently publishing a paper on a false paradigm in thyroidology, the diagnosis and treatment of hypothyroidism, but I've seen it in every field I look at, except for maybe biology and chemistry. Child abuse. I am utterly opposed to schooling children. I think it destroys their philosophical ability, which is naturally developing until they get set in a classroom and told what to learn and memorize. And I think this is why our Western civilization is rapidly deteriorating. It has no philosophical competence whatsoever. And it's just become arguments, of this person's view versus that. The solution is a proper metaphysical theory, which I call cosmism. That the cosmos is what exists and evolves. We know what it is. It's extended for, tens of billions of light years. It's full of galaxies. And here on this earth, it produced us through a process of evolution. I even like changing our language. Cosmos, sun, earth, we should capitalize them. And its foundational assumption that there is this external world, it cannot be falsified or proven. As I argue with James many times, everybody can say there's nothing but my consciousness and you're all delusions created by the matrix or by God. And objectivism is a proper metaphysics, and with an objectivistic cosmic model, you can start talking about what's causing it, whereas you can't with subjectivistic models. They say relativity is proven. They say it over and over and over again. It is not proven. What's proven are these facts. And they have nothing to do with relativity. And that is the Lorentz transformations work when you apply them to the correct frame and not otherwise. Light is a wave in space, has quantized interactions with electrons. This is what the evidence tells us. Not that light moves at c relative to every observer. We know that matter can't move it through c, at greater than c through space, or even at c. Relativity doesn't explain it, it just incorporates it as a rule or law. We know somehow matter alters its surrounding space to create gravity, and I think this is actually what creates matter's inertia also, is the fact that it has this gravitational interaction with space. We know that velocity in space and gravity both redshift atomic spectra, and we need a theory why. And I would say it's very easy to replace relativity in quantum mechanics with space theory. We just have to restore the suppressed space to physics. It's there in the background. Nothing works without it, but it's literally just been suppressed by Einstein's attempt to restrict physics to the description of our sensations and measurements and ignore the physical space that's causing everything. So just replace special relativity with Lorentz ether theory as a module. It works. Lorentz ether theory has been shown by several authors to be equivalent essentially to special relativity. Again, what depends is the frame. Replace general relativity with flowing space, and I will briefly introduce it and then I will stop the lecture there. because flowing space is a theory of spatial inflow, the inertial electromagnetic medium flowing into the Earth, it gives you everything to do with general relativity, and I'll explain why. And replace quantum mechanics with an EM wave theory of light and electrons and their interactions, which is Chantal and Donald Chang's specialty here. We have to start with Newton's space. It is not understood. Physicists don't understand it because they've interpreted it in a relativistic way, but actually it's an ether theory. It's an ether in which matter can move without resistance at any velocity, so we didn't know about c. But matter strongly resists the space itself, resists the acceleration of any matter relative to itself. So you try to use a force on an object and it pushes back. It resists the acceleration. And that implies that matter doesn't naturally accelerate relative to space. So think of this, if Newton's space is not a single cosmic solid, but actually a fluid that can move from place to place or flow or accelerate in some direction, matter has to accelerate with it and would not feel that acceleration. And this brings us to Einstein's greatest insight, which is the principle of equivalence of gravitational and inertial acceleration, not mass, which is what he called it to try to hide what was happening. And you all know about it very well. Standing here, it's like we're in a spaceship firing its rockets, and we're standing on the back of the spaceship. And so his view is that being accelerated by a rocket is identical to being on Earth's surface. And he said it very clearly. It's the equivalence of a gravitational field and the corresponding acceleration of the reference system. And there he uses, a wishy-washy, misleading term, which he meant Newton's inertial space. That's the only physical interpretation of the reference system that is accelerating down through us and causing us to accelerate towards Earth. If we don't have anything under our feet, we're in free fall. We're not accelerating relative to Newton's inflowing space. So it's a fluid that accelerates into all matters into a sink. You all know dialect has nice illustrations. It's also the inertial medium, so all we have to say is it's the inertial and the electromagnetic medium. And there, Michelson-Morley did not disprove anything. Stokes and Lorentz both had explanations. You may know of Michelson-Gale experiment. Michelson said, I'm going to prove there's an ether, and so he proved that there was. This interferometer in a field in Illinois showed a fringe shift. So the rotation of the Earth is absolute. It's luminally and inertially absolute. There's no relativity. There's no general relativity here, or rotation should mean nothing. And I think lastly, I'll talk about the fact that the idea that Newton's space is flowing down through us implies a velocity. And that velocity is very simple. It's Newton's escape velocity. Or as the dialect said, it is the capture velocity. So you release a mass from infinity, let it fall towards Earth in free fall. When it hits Earth, it's moving at 11.2 kilometers per second. I believe space does exactly the same thing and is flowing down through us at 11.2 kilometers per second. And indeed, atomic clocks on Earth's surface slow exactly as if they're moving at 11.2 kilometers per second. And so what we have now is we've incorporated a principle of equivalence of inertial and gravitational acceleration and velocity. And it's all Newtonian ideas, but the space itself has some unusual qualities, and that to go into that is more time than I have. So I'll stop here.
You 10 minutes remaining.
To talk?
Yes.
And then we'll have how much for questions?
You got 10 minutes left for questions, or you can open up for questions now if you like.
Let me just see where I'm going. Well, here's a physical analogy for why atomic clocks slow. Atomic clocks are a little more complex. The electron shells actually are redshifted in the frequency or the wavelengths that they absorb and emit when they're moving through space, but it is actually just Lorentz transformation, the Pythagorean theorem. This is atomic clock slowing in a simple physical analogy. Black holes are perfectly explained by flowing space, and this has been written repeatedly by many authors, even Max Tegmark on a BBC television show said it explains everything about black holes. It works perfectly. But yet they will never apply it to weak gravity situations. And I've written to several of them who've written about black holes working by flowing space. They will not talk about it in normal gravity for some reason. But it works, as Dialect showed. Look how much simpler the equations of flowing space are than this crazy Schwarzschild metric that Einstein couldn't even figure out himself. And whenever you look at the equations that are used for basic things, they're flowing space equations. V squared is everywhere. In light bending, in the light orbit radius, how light would travel around a mass, and so forth. So in essence, there's never been relativity. We've always been detecting motions relative to space. As Newton said, you're accelerating relative to space when you feel a force. And so the acceleration, the natural acceleration of any object anywhere in the cosmos in free fall shows you how space is accelerating at that point. The slowing of atomic clocks everywhere show us the speed of space at that location. Nothing relativistic here at all. And a good illustration by these are moving with the acceleration of space, these masses. Only the acceleration, whereas light has to follow its flow. It moves with the actual flow of the medium. GPS is flowing space. It works by flowing space. There's no relativity in it whatsoever, even though it's considered, a bastion of the proof of relativity. Why do I say there's no relativity? Has anybody tried to do the GPS system from one of the satellite clocks? Can you do the calculations to get the entire GPS system from one satellite clock, or from an observer flying by? From a rotating observer out in space somewhere? No, none of this works. What works is you take the center of the Earth and you apply these flow equations, Newton's simple flow equations, and it works. It works. Newton's velocity and the tangential velocity through this inflowing space that is Earth-centered but not rotating with the Earth gives you all of the GPS system's functions. It also predicts clocks. If they are falling with space, they should run fast. This is a testable prediction. And light would travel minus C up plus, C plus V down. And I think I'll stop there. I have a lot of things I could say. Questions? Yes, Alexander.
Yeah, thank you for this very inspiring talk. I learned a lot about philosophy. It's a really impressive study.
Oh, that is wonderful.
I'm in agreement with so many points you said, but we don't make progress if you're only agreeable. So
yes.
To the point where I think you took it a little bit too far.
Okay.
And it's worth remembering the different concept Einstein and Mach had about relativity. Einstein had always in mind the systems, the reference frames moving with respect to each other, whereas Mach, on the other hand, was strictly referring to relative motion of particles in the universe. And I may side with Mach here, but in any case, now let's go to the twin paradox you criticized. Well, apart from, I guess, the evidence we have from muon decay or Hefele-Kittig experiment or whatever comes to mind, I think for me it's pretty much okay to say, yes, there is a difference because one twin is actually accelerated and the other one is not. I mean, you feel that, and if you feel that too strong above 10G, I mean, you just said, you're a medical doctor, that pretty much makes a difference.
Accelerating relative to what?
Yeah, and whatever, I mean, accelerating, you can't criticize the absolute space, fine. You don't accept that, it's okay. If you don't want the Einstein-Newton picture, then you go to Mach. Well, you accelerated with respect to the center of mass of the universe. Okay, but you're dead in any case.
You're what?
You're dead in any case.
What do you mean dead?
Because because you have one twin has too much acceleration. I mean, the one twin.
At 10, if they go 10G. Yes. So
from my point of view.
Yes.
Oh,
right. His point of view on the. I have to repeat it.
Yeah.
A little bit. His view is to explain the twin paradox. We can use Mach's principle. I believe is essentially your point, that one of the twins is accelerating relative to the, I would call it the distribution and motion of the surrounding matter. You know, the bulk distribution and motion of surrounding matter. And in fact, I agree with Mach's principle, and I'm glad you brought it up, because this model of gravity as creating a unique local inertial frame of space flowing into it from all directions, this space is a massless, frictionless substance. I get into characterizing it, but that's a lot more talking. So when the Earth is moving, this flow field moves with it to some extent until it is interacting enough with surrounding masses and their flow fields that you transition from this Earth-entrained space. People call it dragging. Stokes came up with this originally when he tried to explain the Michelson-Morley, and he said, no, space is not flowing through the Earth or past it at 30 kilometers per second, and I believe he was right. So now just expand this to stars being spatial sinks and their spatial frame flowing with them, or following their motion when they're in free fall. If you're accelerating something relative to space, there's going to be dislocation of this flow field. Galaxies then are all massive spatial sinks, or as I can argue, sources of space. But either way, space co-moves with galaxies out to a very great distance, basically to the next galaxy that's moving, nearby and surrounded by galaxies that are all entraining space in their motion. So this gives us, in my view, a physical explanation for Mach's principle. This is why I'm a believer that Mach was correct about that. There is no absolute Newtonian space. That's such an abstract, conception that it's not affected by matter, where it is and how it moves. I believe it is, and with this theory, you also get the bucket experiment. The bucket works because there's always an inertial space everywhere, but its state, its position and motion are determined by the distribution of matter around it and, near and distant. There was a question.
Well, I have several, but
yeah.
Maybe just quickly. What happens in this model if you have two masses and you're in between the two at a point?
Yes.
Where the field is zero?
Yeah, very good question about, how do masses interact? Well, it's amazing. I've thought about it for quite a while. You generally get the Newtonian solution, but say if you put another mass out here and they are both pulling space in opposite directions. What will happen is that if space around them is not under tension, you'll have space flowing from above and below into that Lagrangian point, basically, where there is almost a point of rest between the two. And they think of it this way. This flow field exists in a frame, in a larger frame of space. Other masses change that surrounding frame. So if there's another mass over here, it's causing the space to accelerate towards itself. So it's affecting the inertial frame of this mass. That's one way of putting it. I don't think of it in so much as a tension because of them pulling space in opposite directions. As long as there is no tension in the surrounding space, it will flow into the intervening area. So I think it more of an interaction of accelerations, which would explain tidal forces. So if you put the moon out here and it pulls this Earth this way, it's pulling it away from the space.
I'm just thinking if you put a clock at
yes.
the point in between the two masses where the field
it will run fastest. It can be at rest in space, essentially.
Yes, but is that experimentally different than the situation in GR, for example?
I believe it is, and there's a paper written about this by Tom Martin. He suggested we get a clock and put it at a Lagrangian point. And I'd be happy to share that paper because you might have a little trouble finding it.
The floor is now open to everyone for questions.
All right, I'll go with the back.
Praise first. I thought that was a very interesting, far-ranging talk.
Thank you.
So just a general question, something that's been puzzling me for ages, I can't work out, is why there is such a problem with an absolute frame in physics. I mean, when Einstein came up with all this stuff, nobody knew about expanding universe and all this. I thought the universe was big, static, something. So
They didn't even know there were galaxies.
in that with that worldview, it sort of makes sense to think of that space is an infinitely large something and there is nothing special about anything. But we now know that it's expanding, so therefore it's come from a point. So if you look at it in terms of whatever, with one time dimension as a four-dimensional thing, at some point the Big Bang was in the center, and now it's a big 3D structure. It means that it has a center.
Yeah. Yes.
And so why is there still this problem of saying like, okay, there is an absolute system, and that's what things are.
Well, by absolute, you mean there is a physical space.
No, I'm just saying about the reference system.
Yeah. So there's a center. There's a
separate to this, but why? I mean,
that gets into my point that there is nothing but contradiction and confusion.
Yes.
Because they are using models that deny that there is any absolute point. The question was about, we have a center to the cosmic expansion, so why are they afraid to say that there is something there that is not simply relative to a reference frame? And that's the point. They think like absolutists in a sense, or like ether theorists, when they need to. They put the ether back in, a later slide, when they need to, and they leave it out when they don't want to refer to it because they're good relativists.
The reference frame is coordinate system, and when here we see some accelerating reference frame, we see coordinates to flow downwards. The real thing is always when you are accelerating properly by some force, you see these kind of reference frames to accelerate fictitious. Then I think the proper space is accelerating upwards. And these coordinates are only...
You say it's coming out of a mass?
Yeah.
As a matter of fact, that gives the same equations and the same physical effects. And this is...
That's the way to go.
This is a more advanced, and it may be because it does bring you dark energy, and if some masses are sources, it helps to explain why this inflow doesn't cause the whole cosmos to collapse.
It resolves this problem he asked, because these coordinates are not the conserving amount.
I would just to add, a space flowing outward that is decelerating gives you the same acceleration direction. So a source would look like normal gravity too, plus the escape velocity would be the same, the velocity of space at every location. Yes, James?
So I was thinking about an answer to your question, and tell me if you agree with this answer to Jonathan's question.
Okay.
So the way this is a rather crude analogy, but imagine you and I are planets. Okay, and we're attracting one another, and there's some Lagrange point between us, right? Perhaps an analogy for what's going on here is imagine that the ether between you and I are like a line of sandwiches, and we're like eating the sandwiches towards each other. So the Lagrange point like stays where it is. It doesn't get like torn in two. The sandwich at the Lagrange point doesn't get torn between us, because you don't necessarily have to think of it as like, because all there is the ether. So it's not that like they're sucking ether through space. It's like the ether is the
space.
Places where matter can inhabit. So the two objects are eating space towards one another,
Yeah.
and that's why they accelerate towards one another, and that's why the Lagrange point doesn't get torn in half.
Yeah, and sandwiches are
Does that make
either
sense?
entering towards the Lagrangian to make up for a deficit there, or they are exiting if it's a source theory of this flowing space. Any other questions, Chantal?
Okay, 2 comments. I think there's an easy experiment to falsify or prove your theory. That is by lowering an atomic clock. I think only about 2 miles below the surface, because in general relativity, you would expect the clock to slow down, and in your model, you would expect it to speed up. And from what I checked, and I sent you simulations,
Yeah.
is that the calculations, the atomic clocks are really accurate enough these days that you could clearly detect the difference, even if the density and everything's not perfect, but the numbers are clear. So, and it wouldn't be that expensive. So I really recommend to.
As I mentioned, the flow equations are not that of an ideal fluid. There is volume loss when you use these equations, meaning your cellular constituents of space, whatever its smallest parts are either disappearing or elongating. There's some sort of process going on that is non-Euclidean and non-ideal. So the only problem I have with your idea is I don't really know what happens when it enters mass and it starts to be consumed, let us say, by the surrounding matter. There may be an alteration similar or reversal of what was going on previously. So all I can say for sure is I think there is no motion at the center.
Yeah, so
But-
even going there, right?
but-
if you say their clock speeds up at the center,
Yes.
there's obviously some kind of.
It has to slow down. It has to slow down.
Center and the surface, you would see
Yes.
it's slowing, but it's actually.
It has to slow down.
Decreasing, and in general relativity, it's decreasing, and it's really.
I would love to
it's very
see.
easy,
I would love to see that experiment done, but I'm not exactly sure what it would mean. But we may have to alter this theory, or
consistent with general relativity. So right, and so and the other thing I see one challenge is imagine like your 2 planets, but now we have a ring of planets, right?
yes,
In the center, it seems like the space would flow towards the planets. But where's that space coming from?
well,
Or if you had a spherical shell,
Yeah, as an example, right?
then the ether at
You
the center would
constantly
get
take
destroyed.
away
Yes.
space, like it's going to get thinner. I mean,
yes.
that's the challenge I see.
That is kind of an argument for a source theory, but if you have sufficient sources, space would flow into.
But like from the center, let's say you have a ring of
Yeah,
planets,
yes,
right? And there's no star in the center, let's just say as a hypothesis, right? And
yes.
where is the space
You
coming
may-
from?
Look, we have phenomena we do not understand. They call it dark energy. Now, it may be that this spatial consumption flow has something to do with the increased appearance of gravity in areas where there are large masses in that kind of configuration you're talking about. Clusters of galaxies in particular have extra gravity that we do not understand. I don't know for sure. I would say we start by having a theory that works and we apply it everywhere we can and we see if we have to modify it. And you're right, if it comes to the point where we can't modify it to work, we have to come up with something else. And I agree. This young man was...
One last question.
I'm sure. Okay, how to pose this question? I am interested in trying to turn this idea into, I wrote it that it's on a completely different angle, into actual proper numerical simulation. Numerical GR is extremely hard to do. On the other hand, hydrodynamics, there are multiple well-researched approaches to fluid hydrodynamics, to hydrodynamics in a numerical way. So I was wondering, did anyone actually try to do this numerically?
Yes, it's been done many times. May I?
Can you show? Do you have some recommendations to look at?
I'm getting there. Whoops, backwards. These are a few. There are actually many people who have discovered and rediscovered the flowing space concept Kirkwood is perhaps the first who said this is actually a material medium. This is a substance flowing into. Painlevé and Goulstrand produce metrics that are essentially.
I'll also mention, I think Riemann in 50, wait, no, that's not 50, 1950, yeah, Riemann in 1853.
He did.
Suggested something like this.
Very good. Newton suggested it as dialect.
All right, sorry, we had to get it off there.
I didn't break the program, the simulation.
Huh? Oh, with simulation, Chantal is the expert there.
I write a lot of simulations. If you give me your email, like.
Send me the break into the next.
We'll talk. We can talk all the time. Thank you. Thank you.